near my microphone. Sorry about the delay there. Welcome. If you're new here, my name's James. I'm a product designer, and I'm interested in designing products to do with music instruments, music devices, electronic devices, all those kinds of things. So if that's what you're into, you're in the right place. In this stream, I'm going to be lowering my brightness a little bit. In this stream, I'm going to be doing some CAD design, some CAD modeling, CAD design in SolidWorks for a project currently called Live Drum Machine, or LDM. And it is a device which, let me show you, currently is looking like this. Matt, thanks for the follow sub. Not sure what it was. So currently looking like this. Pretty basic. It's just a box, a folded sheet metal box with a display. That's all I've gotten up to at this point. But it will be something like, let me just bring it up. I'll just bring up some inspiration images in 1 second. Sorry, I should have organized this earlier. Okay, here we go. So these are inspiration devices. It's not going to be anything like one of these in particular, but it is going to be a digital drum machine, so an electronic digital device which you can play drum loops, drum sequences with. There may be some playable elements like we see here with the sticks hitting pads. There will likely not be so much sequencing, but more like looping kind of functionality. But it's essentially designed to be a device which you can play drum beats with, and it should feel like a musical instrument. So it shouldn't feel like you're programming something, but rather you feel like you're actually playing a beat. And when somebody watches you playing it, they should also be able to recognize that you are playing an instrument and that there is some musical feel to it, and it's not just pressing buttons and programming in codes and stuff. So that's a general scope of the project. I'm not working on it alone. There's 5 of us, so mostly friends and ex-colleagues. Yesa is kind of the I don't know, the catalyst, I guess. This is sort of his baby project, and I'm just doing the mechanical design, but I'm also helping with some UX stuff and overall concept development. But in these streams, because we don't want to give away too much of the secret sauce of what's going behind the usability, because that's kind of the most important part of the IP, I'm just doing the CAD modeling. So that's what I'm showing you here. And there will be some more streams coming where hopefully Yesa can jump on the stream, and maybe some of the other guys doing the electrical design or PCB design and circuit design and stuff and firmware. And we can give a little bit more background into those other areas and what kind of functionality and stuff you can expect from the device. But for now, we're doing CAD. So if you like CAD, you're in the right place. And we're doing it in SolidWorks because this is what I've been trained in, and this is what a lot of companies are using in the industry. And it has a few key features that I find are missing from some other software, like Fusion 360, for example. And the biggest one is, and I need to clarify that I haven't seen this functionality in Fusion. Somebody has told me that it's possible, but they haven't told me how, so I need to investigate. But I think the most important functionality here for me is if we look at this sketch and we look at this extrude feature, I'm extruding from a vertex to a vertex. So I'm extruding this, the depth of this extrude is going from this point to this point which is these are points on my skeleton model. And this feature is critical to me, being able to select a vertex as a start and end point. Because as far as I know, and please, if I'm wrong, show me, but as far as I know, in Fusion, you can only extrude from planes or from faces, which, you know, they can be helpful in some cases too, but I find it much better to extrude from vertexes, because then I can just have a skeleton model which has all my sketches in it, and everything can be linked to the sketches. I don't want to go too much into depth why that's a good way to do it, but I've been doing this. Actually, I probably only started doing skeleton modeling maybe 5 years ago, 6 years ago, but I've been using SolidWorks for about 10 or 11 years. And yeah, you know, I'm sure there's people who have better ideas than me, but this is what I've come to in that time, and it worked well for me. So I'm going to close this. Where I got to last time is I was starting to add in some jacks. And the first one I thought we would add is a 1/4 inch or 6.35 millimeter TRS jack. Something like you can see here, these jacks here. So likely this device is going to have 2 analog audio outputs, and they'll either be 1/4 inch jacks like this, or they could be XLR. Not entirely sure yet, but we will likely also have a couple of inputs. Not exactly sure what those inputs are going to be yet either. Whether they're just for audio, for sampling and things like that, or if they're for some kind of drum trigger. Oops, zooming the wrong way. So this kind of device or another drum pad could be used as a drum trigger, and it could be nice to have some trigger inputs here. Something like you see on a electric drum kit, where you can plug a snare drum into the snare brain, and you're plugging it in as a trigger. So I'm going to add in some of these jacks. Maybe we use them, maybe we don't, but at least I can sort of start laying them out. And we're also probably going to have full-size MIDI jacks, so I'll add them too. We'll either have a USB type B, which is this one here, or USB type C. Not completely clear yet. You know, maybe we would power the device with USB-C, maybe we'll power it with a barrel jack like this, but I'm just going to start adding some things in. We can block them out, and then we can make definite decisions about this later. But this is all just about like getting stuff in there that we can start moving around, playing around with things, try to figure out the architecture of the internal architecture of the device. Okay, so let me just find here. I have the project folder, and I made this components library last time. So we have our example display, a 7-inch display, which is in there, which is just a placeholder for now. We'll choose an actual display at some point and put that in there. And I got this Amphenol jack, which I have made I've got the data sheet here. I've got the step file, which came from their website, and I've turned that into a SolidWorks model, which just gives me a bit more freedom. And I can add some, no, I don't want to do feature recognition. I can add some details to this, like a dimension sketch. So this is important for my skeleton model. So if I turn off all the solid bodies, I can see here I've got all my dimensions, which should match with the data sheet that I have here. So why is that so zoomed out? Let me zoom in a bit. So I've only done a sketch from the top view, which has all of these dimensions. Now I need to do a sketch from the front view so that I can get the height of the jack from the PCB and yeah, all this extra data, because I'm going to put this all into my skeleton model. So this is good from the top view for now. If I want to put a if I want to make a movable copy of this in my skeleton, this might seem a little bit abstract now, but it's going to make sense later. But I need to have like I want to make another sketch of this in my skeleton where I can make all the lines equal to the lines in this sketch, so that I can move that sketch around and it'll stay the same proportionally to this, but I can move it anyway. But in order to do that without adding dimensions to this copied sketch that I made, everything has to be positioned with geometry. And this line, for example, its vertical position is only defined by this dimension. So if I am not going to have a vertical dimension in this other drawing, I have to define this with geometry. So what I'm actually going to do is I'm going to break this line here, and I'm going to put a point there connecting it to this line, because then this section of line I can make equal to the section of line in the other drawing, and then it'll be proportionally the same without having to add this dimension there. Maybe that is flying over the top of people's heads right now, or maybe I sound like a crazy person, but you'll see eventually. But what I need to add is a shortcut here for what is it called? Something where you can create, you can make a, there we go, split entities. That's what I want. So I want to put that here. This tool allows me to split a line into two lines. Okay. And what happened there? Something weird. Yeah, this dimension. Okay, I'm going to join that line to there. So now this vertical height I can copy, and this line, what's going on here? I'm gonna split this one as well and put that there, and then I just need to dimension this line. Okay. And this line's vertical position also isn't defined, so I need to split this again and link it to that. This will all make sense soon, don't worry. Okay. So now I'm going to do a sketch on the front plane. And I can show this. Whoop, what happened then? So I basically just need a rectangle and a circle, maybe two circles. Maybe I'll do like the inner diameter and the outer diameter. The pin depth could be relevant too, maybe not, I'm not sure. Okay, so I'm gonna hide this again. Put in a rectangle. Connect it to this. So our width is defined. And whoops. Then I need the height, 12.7. Okay. Then the jack hole I guess you call it. I'm gonna put some horizontal lines here because then I can make them, oops, that's not what I want. I can connect this line to this line, that's the center line. Then this outer line I can make horizontal with this. And then I need to define the height, which is 6.5. That's not what I want. Actually, I don't need to break this one into segments. It's probably easier if I just have that as one line. Okay, 6.5. And the inner diameter is what? Does it even tell me? No. Well, we know that actually, I don't really need the inner diameter, now that I think about it. Because we know what plugs into it is 6.35 millimeters, but there's nothing in my model that needs to have that dimension, I don't think. It's only going to be this part which might stick through the enclosure, so I'm going to leave that there. We have on the dimension drawing a panel cutout, which is the hole that would be needed for fitting this through. But I think that's going to be to fit the entire thread through. But I don't actually want to put the thread through the hole. I think we're going to do it without a nut. Might sound risky, but I think it's fine. This has a screw hole in the bottom, so we can actually screw it in from the PCB, and that leaves the outside looking very clean. So panel cutout is 11.2. Let's just put that in there and see. .2. Yeah, so it's actually even wider than the thread, which I don't think we need that. So I'm going to leave it out. I don't even think I'll put the thread in there. I think that's all the information I need. I've got the pins. I didn't put these pins in there though. These are like locating pins. So I should put those in. Yeah, okay, I'm going to do that. So I'm going to name these front reference. Why is it so hard to bring up the rename dialog? Oh. Top reference. Okay, so go back to my top reference. I'm gonna use my split entities again, so I can split this line and make these horizontal. were they again? So 7.45. P flop flop. Thanks for the follow. It would be great if this if there's, what do I call it, alerts told me which platform it's on. I'm assuming Twitch. Thanks for the follow. Is it P flop flop or flop flop? P flop. Sorry, what am I doing? 7.5 was it? 7.45. 7.45. Okay. And I should probably put the diameter of those pins in here as well. Make those equal. Does it say the diameter? Ah, I remember last time I was getting confused about the two diameters, but it's for two different pins. So that one's 3, this one's 2. Okay. The second one, flop flop. Okay. Great, that's very easy to pronounce. What are you working on there? I'm working on a drum machine. It's a digital drum machine. I can show you, like, inspired by these kind of devices. But it'll be something like a drum looper, I guess. And it's a standalone hardware device, and it will be digital. So hopefully that's not too contentious. But yeah, it's planned to have probably like a Linux-based system on module running software inside it, which sounds pretty complicated, but I'm working with 4 other guys who are pretty knowledgeable with this kind of stuff, so sounds great so far. I'm glad you like it. Thanks, man. Yeah, I guess some people, I don't know if you're coming from just an interest in design or an interest in synths and stuff, but yeah, some people in the synth world really don't like digital stuff, but come on, you know. It's a bit of a conservative mindset, but analog stuff is still cool too. But yeah, digital is also good. Okay, so what was I doing? Okay, now I've got my jack here, which it was a step file that I downloaded from Amphenol's website. I turned it into a SolidWorks model, and I added 2 sketches here, a top reference and a front reference, which is kind of like having the data sheet inside your CAD model. And I'm gonna show you now why that's a good idea. So if I go back to my drum machine, and I go back to my skeleton model for my drum machine, and I drag back to the top here, I'm gonna insert my jack without body materials, part materials, or any solid bodies or anything, only sketches. So I insert that, and then all that's been inserted is the 2 sketches, which is great because I can use these sketches to create some movable geometry in my PCB plan. So if I go to my PCB sketch, well, what I should do, just to make life easier, is I'm going to rotate this because the jacks are going to be at the back. And I can do that by changing the way I inserted this. Locate part with move copy feature. And I'm going to use mates. So I'm going to mate the... I need to bring in planes. So I need to edit this. Bring in planes. locate with move and copy feature. I'm going to mate the top plane with the top plane. So that's all good. And then I'm going to mate the front plane with the front plane, but I'm going to reverse it. Reverse it. Reverse it. Why didn't that work? Did it work? Maybe. Let's see. It did work. Okay, the preview just wasn't showing it very well. By the way, flop. If you're still there, I don't know. But and if you want to talk, tell me a bit about yourself. Like, are you a designer as well? Like, what brings you here? Or are you just browsing? And tell me if my pronunciation was good. Okay, so I'll go back to my PCB top. I'm gonna hide the front reference. So now I want to make a movable version of this jack that I can move around in my PCB layout. I'm also going to show the enclosure top, because the jack's going to go through the enclosure. Alright, so I want to make a movable copy of this with all of the geometry, but no dimensions. So I'm actually gonna how can I do this? Alright, I'll do that. Convert all the entities. Convert these two. Then I'm going to delete all external references. But I don't want to delete everything. Wait, what sketch am I in here? I'm in the enclosure sketch. Idiot. Convert those as well. Failed, why? Whatever. External references. I think all these on edge ones I need to delete. It's not going to delete anything else. Yeah. So that's just deleting all the ties back to the sketch that I just copied it from. Oh. And then I want to move it. Okay. Make all of this construction geometry. Once again, this seems time consuming, but once this is all set up, this is all for the greater good of having a totally custom or adaptable design where I can change everything later. So I can see I'm missing one line here. So now I want to make a copy of this because I'm going to have at least two. What would be great, actually, I'm going to demonstrate this later. So hopefully either SolidWorks can change something, or somebody can teach me something. But okay, make those equal. Let's do all the construction lines first. Make those equal. These equal. These. I'm gonna do something here so I can tell when it's defined. This is annoying. Okay, these don't have horizontal and vertical definitions. Oops. Not definitions. What do you call it? Relations. Shouldn't have done the convert entities thing. I think that was a long way to do this, but don't worry. Okay, so I need to make these equal. This needs to be equal to this. Probably need to split this line. Okay, come back. Wait, I'll just explain why this is important. I think I almost explained it before. So I'm not going to be able to define where this should be positioned horizontally unless I have a line segment, which is, actually I can use this. Yeah, that'll work. I have to have a line segment which is attached to this middle point, so I have some kind of dimensional reference for where this should be. And that needs to be linked to this. And this needs to be connected to this. And why? Okay. Alright, so now this is defined and this is defined. That's what I was hoping for. Okay. All these points are disconnected from each other, which is very annoying. I definitely didn't do this the ideal way, but that's all right. I make this equal to this, and this equal to this. That should define it. Yep. And then this equal to this. And that needs to be horizontal. Another thing I could have done, instead of making them all horizontal and vertical, is make them like right angles to each other, which can also be a good idea because then you can rotate this, but I didn't do that, so I probably should have. But I don't think it's going to be a problem for this device. I think it's only going to have jacks on the back. So, are these equal? They are now. This equal to this. These horizontal. This equal to this. These two equal. These horizontal. This equal to this. These horizontal. And this equal to this. Okay. So now if I disconnect that, I have a movable version of this jack where everything is proportional as it should be. Yeah. I think that's... Was there something else I forgot to do? I can't remember. Oh, right. So now this is the problem where like I want to know if somebody has a solution for this or if SolidWorks has a solution for this, but if I copy and paste this, all of those external references are lost. So it'd be great to know if I can paste with external references. Maybe I'll quickly Google that. Paste sketch with external references. Yeah, there's a page that's like copy sketch and maintain. Oops. Why is that timer always there? Copy sketch and maintain sketch relations. So the relations are all there, but it's the external references, so I don't think this is going to help. I'll try and find that out later. But anyway, I'm going to have to do this again. But at least all the horizontal and vertical relations and everything are still there. Why didn't it like that? Okay. Apologies if this is a bit boring. Almost there. One more, two more, one more. Okay, now I have a second jack which is fully defined once its position is defined, and it's defined in relation to the sketch that I imported. So I can hide that now. And yeah, now I have 2 jacks, which I can move to wherever I want, and they are defined with all the dimensions that they need. And they don't have any dimensions in this sketch that are making things look messy. So I want the opening of the jack to be flush with the outside of the enclosure. So I'll connect this to there just by dragging it on, letting it become coincident. Then I can define how far apart from each other I want them to be. Let's say 20 millimeters. And I can say that, I don't know, I want them some distance from the edge of the device. Let's say 80. This is all going to change, so it's just temporary. But yeah, for now I just want the sketch to be fully defined. Then we have our PCB. We have a PCB right sketch, but I should also make a PCB front sketch, so I can put the jack holes, I guess, in there. So let's make a new sketch on the front plane. And PCB top and PCB right, we can put in where the PCB will be, which I can link to the height of this, and I can link to the width of this. And then I need to make some movable versions of the jack. So I'll just do a rectangle, a circle, now I don't have the position horizontally here, so I can either split this line or I can add a little line there. I think I'll do that. So let me just do this for now. I made those equal, but I actually just need to make this equal, or either or, but I can't define that. So let me go back to my front reference and just add a little line segment here. Come on. I think I can brighten up my camera a bit now. Oh, wrong way. Okay. It wants me to lock it. Don't know what that means, but whatever. Oops. need to go back to my skeleton. Then I can make this equal. Okay, now we have a fully defined movable jack. I can copy and paste it. I have to do those relations again, unfortunately. If any SolidWorks experts or SolidWorks staff are watching this, can you tell me if it's possible to copy a sketch with with the external relations? Okay, now I have these two. The height is going to be, well, they're going to be sitting on the PCB like this. And if I show my PCB top, the center line is here and here. There we go. Can hide that. So that's going to be where my jack holes come through the enclosure. So does jack hole sound like a swear word? I don't know. PCB front. Okay. So now I've got my PCB front and PCB top. And I'm gonna have a sketch for rear holes in the enclosure. So I'll also put this on the front plane. And I'm going to put some holes based around these jacks. And I'm going to put a little line there to define the offset. So how much bigger these holes are going to be than the jack. And I might make it 0.5 of a millimeter gap around the edges. And I can just define it once and make my other line equal so that my other circle is equal. Okay. I'm going to call this, if it lets me rename it, rear holes. Show us your rear holes. Sorry. Okay. I've got a lot of messy new sketches shown in here. I'm just going to hide them because I'm OCD like that. Gonna have to hide them for every part, every unique part. So it looks like what I'm doing is doing nothing, but it's actually, it's actually like every unique part has this sketch in it as well. So I have to hide it, all the overlapping versions of this sketch. And why can I still see it? Oops. Whatever. Sometimes it'd be like that. So I'm going to make some holes in my enclosure. So I'm going to turn on rear holes. Actually, no, I'm going to put a sketch on the front plane and just copy my rear holes. It looks very high, doesn't it? Extruded cut. Oops. Through all. Yeah, so I think that is telling us that our PCB is too high, but we'll see. When we go back to here, I'll make this transparent. Yeah, so it looks like our PCB is too high. So what I'll do is I'll put the jacks in and we can see just how high it is. So I want to insert that part, and I want to do it twice. Actually, no, I'm going to do it once, and then I'm going to copy the mates. So I'm going to make the front plane with the front plane in a reversed direction, the right plane with the right plane parallel. I should have also done that with the front plane. Let me just edit that, mate. Should be parallel, not concentric. And then I want to turn on my PCB right. What's happening? Oop, bit slow. And I'm gonna mate the top plane with the top of the PCB. And I'm gonna turn on my PCB top. Mate the front plane with the front of this jack, and the right plane with the center of the jack. Okay. So our jack is in place on the PCB, and yeah, we can clearly see that this PCB is too high in the enclosure and the jack's sticking out the top. So I'm gonna have to make some changes there. But first I'm gonna put in my other jack, and the way I can do that is by clicking this one and choosing copy with mates. So this parallel mate I want to repeat, this one I want to repeat, this one I want to repeat, which is the height of the PCB, and these two are just about the position. So the front will be there and the right will be there. Bang. Okay, now I've got my two jacks positioned exactly where they should be. And I'm gonna turn all these sketches off. No idea why these ones are still showing and why I can't click on them. It's kind of bothering me a little bit. Whatever. Okay, so we need to make these jacks a lot lower. And I think a good way to do that will be if we can actually see in the PCB right sketch how high they are. So I'm going to go back to my jack, and I'm also going to add a right reference. Yeah, I'm going to make the main switch body like this. Switch body, jack body. And I'm just going to define all of this with the other sketches, not with the bodies. So that can go there. There. Do a center line. Whoa. Mm. Okay, I will link it to the geometry. Oops. Oh, that's bad. Why is that angled in like that? What did I even link that to? Whatever. Alright. And I just need a line to define the height. Should be this one. Cool. Maybe I can even just copy this. Problem is that it's facing the wrong direction. Right, reference. Okay. Gonna go to my PCB right. Yeah, if I paste it here, it's facing the wrong way. Can I flip it? Maybe I can scale it -1. No. God damn it. Mirror? Mirror about this. It's gonna have a mirror reference. So annoying. Stretch. That wasn't stretch. This is move. All right. Does anyone know how to do this? Whatever. Drawing it from scratch. Okay. Ah, right. Almost there. There we go, now it's fully defined. Now we have a right plane version of this jack that we can move around. So, what happened? PCB top. And I'll align that with that. Okay, so now I can see, if I put my enclosure on, I can see how high it needs to be. So I can get rid of this height definition of just a random number of 10 that I put in there. And I'll hide this. Now I can move the PCB down with the jack, and I can define how high I want the jack to be from the top. And it could be that we say like, okay, I want the top of the enclosure actually to hold the jack down, so that if someone bends on a cable here, it won't push the jack up because it has nowhere to push it. So I could do that, or I can define some small gap there, say 1 millimeter. And this height is going to be determined by other things as well, like the buttons and all that jazz too. So yeah, it may be that we want the jacks to be further down on the device too, or maybe we put them on the underside. So that's also a possibility. And if I do that, then I'm going to have to rotate all those sketches, which will be annoying, but whatever. Cross that bridge when we come to it. Now, if I update the model, look at that parametric beauty. That should be showing. And hide all these sketches. Still can't hide those ones. But yeah, so now just updating the skeleton model. All I did was move the position of the PCB down. That moved my jacks, and it also moved the holes in a completely different part. So that's the great thing about parametric modeling, is yeah, everything is linked and everything updates. God, that annoys me that these sketches are showing. Why are they showing? PCB front and weird. Don't know why I couldn't select those. Ah, because they're on a transparent part, and you can't click transparent parts. Makes sense. Also, don't do that SolidWorks, but makes sense. Cool. So got some jacks. They look very high on the device. And you know what? Maybe I want the whole device just to be shorter, because I see no reason for it to be that big yet. There we go, now it's 30 millimeters tall. Oops. Plenty of room. Look at that. Probably the PCB will be a bit lower than that, but we'll see. What should I add next? Oh, maybe actually I'll put the holes in the PCB for these locating pins. The actual solder pin holes, I generally leave that to the EE guys, like whoever's designing the PCB, because they will they'll have the pad layout for the jack, and they can put in these holes, and yeah, they can choose to use these pinholes as a locating point for actually locating the jack. Either way, there's lots of ways to locate it. I generally provide a drawing of exactly where everything should be located for the guy designing the PCB. But just for the hell of it, I can go to the PCB part, and I can turn on my PCB top, which is all out of order for some reason. And I can select all of these. Actually, maybe these holes should be a bit bigger. Make them all equal, make these equal. And maybe make it I don't know, 2.2. Probably needs to be bigger than that, but whatever. 3.2. Then I can extrude a cut. Through all, yeah, other direction. There we go. Now, because this is all linked to my skeleton sketch, they should be exactly where they need to be. Boom. See that? That's parametric modeling. Okay. What to do next? I could put in more jacks, I could put in some buttons, I could put in knobs. Or I had an idea for this display protector problem, which I was trying to describe last time on the stream. Let me just bring up Paint. Trusty Microsoft Paint. Okay, so what I explained last... Whoa. Can I draw a straight line on here? Is there a button I can hold? Maybe not. If I was to CNC machine this top plate, what I would do, well, let me explain all the options. This is what you do if you just have a square hole like this. You can CNC cut a piece of acrylic. This is looking from the side view, by the way, like this. And that fits up into the enclosure by pushing it in this direction, and then you glue it here and here, and that's your display protector, and your display is underneath. The problem with this is that if you push down on it from the top, like if you actually push it with your finger or something, it could pop out, or it could damage the display. So an alternative would be, if your enclosure was machined, you could actually machine, sorry, there's another problem with that. With this shape of display protector, you can't just cut it out of a flat sheet. You also have to machine these steps, which is time consuming and expensive. Now, if the enclosure was machined, you could machine a step into the enclosure like this, and then just put a flat plate of plexiglass or glass or something over the top. That makes the plexiglass much cheaper and faster to produce, but CNC cutting the enclosure top takes longer and is more expensive. So what's my idea? I want to avoid machining if possible, because machining, it's expensive in low quantities and it's even more expensive in high quantities. It's just not really that viable for mass production. People do it, but it's expensive. Cutting flat sheets is much better. So my idea is to do 2 layers on the top sheet, on the top of the enclosure. So if I have one layer like this, and then one layer like this, they're not even aligned, and then my screen protector like this. Now last time I said like, yeah, I just put a little ring around there like that, but what I figured is I might as well make the whole top of the enclosure 2 plates thick, like maybe make them 1.5 millimeters each. And there's benefit to doing that, because I can not only have this step that the enclosure can rest on, but I can also do things like put in screw bosses, like a screw boss like this, which is put in from this side, from just in the first plate, and you can see it on the top. But if I put this other plate on top, then it hides it. So yeah, I can put in things like that, which will be hidden. You can do other things like I don't know, say I want a recess for a button. I can have a hole that's cut out here so that the button has more space underneath it. It essentially gives me 2 levels of like kind of machining, but I can only machine to like halfway through the material. But I can do that anywhere, so gives you a lot of extra flexibility. And then fixing these 2 plates to each other could either be with adhesive, or I could spot weld it or something. Have some little holes that welding can go through, or just have a spot welding machine does it, and then they just get painted together once they're already attached. Painted or anodized, I'm not sure yet. So that's my idea. So maybe I should put that into the design for now. So what I want to do is go back to my enclosure right, and what I'm going to do is I'm going to leave what's that? I'm going to leave this as it is, and I'm actually going to reduce this to 1.5 millimeters. Then I'm going to add a second plate, but inside this, and that means that the walls of the enclosure will like fit around this plug kind of thing, I guess. This may or may not be a good idea. We'll see. Might make it harder to assemble. Yeah, we'll see. Assembly will require some gap here. Actually, I'm gonna put that gap in the enclosure top because the front gap might need to be more so that you can slide it in, or the back gap. We'll see. Let's call this oops. What do I call this? Top plate 2 thickness. And this would be like a sub-assembly, so I'll have to figure out what the naming would be. I don't know. Oh, my enclosure top is after this. Okay. I'm just going to make this go to the edge. I can define the gap in the other sketch. Does that make sense? Yeah, should make sense. Okay. So I actually want to rename this to I need to change a setting so that I can rename things in the timeline. How do I find that setting again? Feature manager. Thought it was in feature manager. Alright. Let me Google it. SolidWorks rename parts in assembly. Tools, options, system options, feature manager. Allow components to be renamed in feature manager tree. Tools, options, system options, feature manager. Tools, options, system options, feature manager. The button doesn't exist anymore. Oops. It says there should be an option to allow component files to be renamed from feature manager tree. Which version of SolidWorks is this? Who knows? Okay. 2023. Same thing. SOLIDWORKS 2023. Tools, options, system options, allow component files to be renamed from feature manager tree. Where is it? Whatever. Okay, doesn't want to let me rename it. Let me write this down, something I need to work out after. Rename, and I'm also going to look into copy sketch with external references. All right. So what I was going to do is I was going to rename this one to 001-1, and then this new one to 001-2, and then the sub-assembly of those we called 001-A. Yeah, gonna have to work out how to do the renaming later. But I have made a second part here, and I'm going to make the extrude start at this vertex and end at this vertex. Then I'm going to create a new assembly. With these two parts inserted. So now we got this double up layer. And I'm going to name this. Yep. And C 001-A. Okay. Go back to my main assembly. Now this is where what I explained in the last stream or the one before, where it's really valuable that all of your components that need to be mated in the assembly are not mated to other parts. They're only mated to either the origin planes or points on the skeleton sketch. And I said the reason why you don't want to mate parts to other parts in the assembly is because something might happen where you need to remove a part, or you want to remove a part, and then if you remove that part you lose those mates. And in this case I'm going to remove this part because I'm going to replace it with a sub-assembly. So I delete it, and then I don't lose any mates. Everything is still fully defined because I didn't mate anything to that part. Then I can insert my sub-assembly and use that instead, and everything is still working just fine. Okay. Now, obviously the shape of this is a bit weird, so I need to define what the shape is going to be in my top enclosure top. Which is going to be a big rectangle. And that big rectangle. Oops. Let me just make it a bit smaller. Gonna give it rounded corners so it doesn't stab anyone. Gonna make them equal. Tangent. Gonna trim the corners. Then I'm gonna define the distance to the top. And all the sides. And I'm going to make the distance to the bottom different so that when I have like a box like this and I got to insert something that needs to go down and then go this way because the jacks have to go through the back wall. I want it to go down and then move across here. So if it's going to end up like this, okay, then this can't go down here because that would block it from going backwards. So it, oh my god, it needs to go like this or something. Probably that distance needs to be more than the thickness of this material because that's how far it'll need to go back for the jacks to get out of there. Okay, so that needs to be at least 2 millimeters. I'll make it let's make it 3 millimeters. Then this, and this can be equal, and they can be like 0.5. This can be 2. And that means that the PCB also needs to be the same. So I can make that driven and then just link that to the enclosure top. Okay. Okay, so I'll go back to my top plate 2. Change the shape of it. Need the enclosure top. And I'm going to break my external references. Which is all of them. I want to put it in the skeleton. Oops. So I have top plate, and I want top plate 2. Wait. Sorry, I'm thinking. Maybe that thing that I just added into enclosure top should actually be in top plane 2. Top plate 2, I should say. Yeah, I think that's what I'll do. Saves this sketch being so busy. Yeah. I'll link the PCB sketch to it. Come on, let me rename. Top plate 2. Need to break this link. Why does that have dimensions linked to it? Gonna risk it. See if I lose anything. Nope, okay. Come on. I don't want it to be linked to the middle point, because it doesn't need to be. Sometimes that can make things a bit annoying, they get broken. Lost this corner somehow. Okay. Top plate 2. can link my PCB top back to top plate 2. Accidentally linked it to the midpoint. There we go. Okay, now go back to this part. Top plate to convert entities. Top plate to convert. Hide all my sketches. Okay, there we go. Got my 2-layer plate, and I can isolate this subassembly and see that, yeah, it's two plates stuck together with a kind of lip around the edge. Now I need to make this part smaller for the display protector, or this part bigger. So what I'll do is I'll put I'm going to put a display protector drawing in here. I'm going to base it on the display. Gonna have 2 rectangles with rounded corners. Whoops. And I think what I'll do is I'll make the outer radiuses concentric with the inner radiuses. Because I think that visually looks good. I'll show you what I mean. So if I do this, where's the midpoint? Yeah. Wait. Sorry, doing a bit of speed catting here. Alright, make those equal. So, oh my god. Okay, I've got my screen size there. Let's say I have a 2mm radius in the corner, and I want my display protector border to be 10mm. If I also make this radius 2mm, in my opinion, that looks weird. I mean, it's not horrible, but it's like, this corner looks super weird, like this being the same as that. It's like, I don't know. It's not my vibe. Maybe we change it to be like that, I don't know. But I much prefer when these are concentric. Oops, wrong button. So it actually looks like something that's bent around that inner radius like that. I think that looks better. Sorry. Other people are free to have their opinion, but that's my opinion. Okay, so I'm gonna call this display protector. And I'm gonna have a center point there. So I can make a movable version of this on my top plate. Can this all be construction, please? Okay. Hide that and then show. No, this goes in holes. My bad. Top holes. Top plate. So actually I want to get rid of this. Put in this. Link it to my PCB top. Give it these dimensions. Okay. So this will be top plate holes. Then I also need top plate 2 holes. This is starting to get confusing. top plate, 2 holes. Okay. I don't know why that question mark is always there. That's better. Looks like that updated okay. And then this one, gonna delete that and get the top plate 2 holes. Yep. Okay. Then my assembly looks like this. And this is where my display protector will slot into nicely. Let's check. Oh, and what do you know, my display protector already fits. Display protector is this one. Yeah, okay, because that was linked to the top holes. Perfect. Why is there a sketch showing? Where is it showing from? Oops, what did I do? I closed it. Just gonna close everything. Except for the skeleton. And open it back up. Okay, sweet. So now I have a display protector which is actually slotting into the device, which is pretty cool. And I think I'll probably just have like a black border around here. Yeah. I like how that's looking. I've got some random jacks here. So, do I keep going? I'm supposed to be meeting up with some friends. Maybe I'll call it there for now. And yeah, in the next one I will either put some other jacks in there or I'll put some knobs or buttons. Might try and find some mechanical switches and see if I can fit those in somewhere. But yeah, cool. Might look like not much has changed since the beginning of this 2-hour session, but I think getting those jacks in there was a big thing. PCB also needs to come down a little bit more now that I have that second plate in the top, but I can worry about that later, or I can make a cut in the top plate. Yeah, but I mean a lot has changed, and this solution I think is pretty cool. As long as I find a way to join these 2 top plates to each other, I think that's a pretty good solution. And if I decide to just make this machined, then that will also be really easy. I'll just turn this into one part. Yeah. For now, I think that's good. If you got something out of it, that makes me happy. And if you want to do something for me because you got something out of it, it'd be much appreciated if wherever you're watching, just follow or subscribe or whatever. Ideally, I would like people to watch on YouTube, because that's kind of the place that I'm focusing on the most. But also Twitch is good. I'm gonna keep streaming on Twitch, so yeah, follow on Twitch is also appreciated. Give the video or the stream a like if you can. I think that helps get some, exposure and get it in front of more viewers. And if you have any ideas or any questions or something, just feel free to ask in the comments. I usually check all the comments, and I'll usually respond as long as they're nice comments, or not just I don't know. Nobody said anything crazy to me, so as long as it's like not just pointless abuse or something, then you'll get a response from me, most likely. Yeah. Hope you enjoy, and I'll be back, I don't know, some point in the very near future, in the next few days, I guess. So yeah, have a great day, and see you next time.